Well, welcome everybody to our Michigan Solar Story, our Thursday evening Zooms. And as most of you know, I'm John Sarver, and I kept facilitate these evening Zooms. And I need to thank our sponsors: the State Department of Environment, Great Lakes and Energy, Eagle, Homeland Solar, Sumter Solar, Harvest Solar, and Shree Energy. And tonight we have Phil Rausch coming to talk to us about Hemlock Semiconductor. He's the Senior Vice President for Commercial Sector for the company. And some interesting and very big developments have been happening up in Saginaw. And he's going to kind of bring us up to date on what's been going on, and I'm sure their future plans. And most of you are probably familiar with Hemlock Semiconductor. It's major manufacturer of polysilicon used for both electronics and solar panels. And so we're lucky to have the company in Michigan. It's a major employer and a major part of the solar supply chain. And go ahead, Phil.
Yeah, well, thanks again for having me, John. Again, my name's Phil Rausch. I lead the commercial for not only Hemlock Semiconductor, but also Corning Incorporated Solar Business. And I'll talk to you about not only what Hemlock Semiconductor does in Saginaw, but also what Corning has invested in recently in Saginaw County. And then also some of our ambitions out in Arizona. Give you a little bit of background about myself. Been at Hemlock for 18 years. I started as a chemical engineer building a large investment at the time, which was about a $3.5 billion capital investment in 2008. Worked in manufacturing for the first half of my career, and then jumped over to the finance team for a little while before working my way into commercial. It's probably not somewhere I ever thought I would be, but here I am, and it's been a lot of fun. I thought it was interesting to join you tonight. I actually got my notice from Consumers Energy today that I hit my 10-year maximum on my net metering rate, and I'm getting converted over. So, long been working in solar industry, but also investing in it personally, and thought it was rather fitting or ironic that I got my letter in the email today or this week. But I'm going to share a presentation with you. I'm really hoping that the video and sound comes through. So let's work together to figure this out.
Well, you see your slides.
Okay, you're seeing the full screen?
Yep.
Perfect. All right, now's the real test because the first click is a video.
"65 years is a long time. Long enough to see computers go from filling entire rooms to fitting in the palm of your hand. Long enough to see the invention of the internet. And long enough to turn portable music players, film cameras, paper maps, and landline phones into a single device we carry every day. And while the world changed in ways we couldn't have imagined,
I'm sorry.
one thing remained at the center of that progress: the hyper-pure polysilicon that makes modern life possible. The material that starts right here in mid-Michigan at Hemlock Semiconductor. For 65 years, the work done inside these walls has supported some of the most important innovations of our time. It powered the early days of Silicon Valley. It helped build the technologies that connect us, and it supports a more sustainable future that is still taking shape. It's fun to look back and see how far we have come. The hair was bolder, the phones were heavier, and solar-powered satellites, not neighborhoods. But progress did not happen by accident. Year after year, generation after generation, the world moved forward. Because people showed up, did the work right, and refused to settle. And so did we. Our progress has never come from machines alone. It comes from people. People who understand that precision matters, that safety and quality are in our DNA. Now, we stand at a milestone. 65 years behind us, and a new era ahead of us. The world will keep changing. The expectations will keep rising. And the technologies we make possible will move faster than ever. This is our moment to celebrate where we have been and to step confidently into what comes next. The next chapter begins now, and it will be written by all of us. 65 years of progress, and we're just getting started.
All right. Now I got to figure out how to get to the next slide. Okay, so a little background about Hemlock Semiconductor. The business started in 1961, originally in Midland before it moved to its current location in Hemlock, Michigan, about 6 miles west of the city of Saginaw. It started producing polysilicon for the computer industry and the first chips, semiconductor computer chips in the world. As a fun fact, the first commercially available computer chip was not available to the public until 1971, and Hemlock started about 10 years before that. Today, we have about 1,700 employees on the Hemlock Semiconductor side of the street. And I'll talk to you a little bit more about Corning's wafer facility, but together there's about 3,200 employees full-time, products for the semiconductor and solar industries. Hemlock is owned by Corning Incorporated, which is you would recognize them as the glass company in upstate New York. They've been making really high-tech materials for 175 years, and this is their 175th anniversary. Owns approximately 80% of Hemlock, and then Shinetsu Hondatai, large Japanese company, owns the other 20%, and it is actually their 100-year anniversary. So a lot of anniversaries in our family. The facility, if you see an aerial shot of it or drive past it, looks like a giant refinery. It is refining silicon instead of oil. You'll see large distillation columns, large fluidized bed reactors, and large production buildings with reactors inside. And one of the things that we're very proud of is approximately 85% of our materials are purchased from U.S. vendors. We started as a polysilicon company in 1961 for producing silicon for the first microelectronic devices in the world. And that is our foundation, and still today we we produce approximately 1/3 of all silicon used in the microelectronics industry. So I guarantee that the device you're talking on tonight, some of our silicon is inside of it. And there's only 4 or 5 manufacturers in the world that can meet the needs of the chip industry. But we also produce polysilicon for the solar industry and have so since the mid 2000s. And with our owner Corning, we've expanded downstream into producing the wafer and the module. And we'll talk a little bit more about the solar supply chain and what it does. But first, we'll share another video with you to get a sense of what we do. So that's a little bit about the supply chain. We work together as one team to make modules for the United States. So polysilicon comes from Hemlock Semiconductor. We ship it across the street to our wafer facility in Saginaw County. We have third parties manufacture a solar cell from our wafer, and then we assemble it into a solar module in Arizona. So like I said, we we started this from Hemlock Semiconductor, and it's kind of the cornerstone of our solar market access platform. And we're building on that 60 years of experience in the semiconductor industry to really continue to grow into our solar future. So again, this is the supply chain. Hemlock produces material called polycrystalline silicon, purest man-made substance in the world. Our job is to take metallurgical grade silicon, it's about the second most abundant element in the Earth's crust, purify it to part per billion impurity levels of various impurities. And then an ingot is formed, and what that process does when we melt it and then pull the ingot out of the molten silicon is we're rearranging the crystal structure into one perfect crystal from top to bottom. And that's why you see the kind of the form factor of it change a little bit, as well as it gets shiny as we pull that single crystal and rearrange the crystal structure so that it actually behaves with the material properties that we need once we slice a wafer and then build that solar cell architecture on top. And then finally, all of those solar cells are assembled into a solar module. You're likely familiar with the US market, but this US solar market continues to grow and continues to expand. And we continue to see this strong growth industry. Globally, more solar is installed than any other form of electricity combined. And even in the US, it has surpassed over 50% of all new electrical generation sources are solar. Increasingly, we're starting to see more and more solar installed with batteries, but we continue to see this be a strong growth industry into the future. And it's really all driven on it is the lowest cost source of electricity. Oftentimes, new solar is cheaper than existing conventional electricity sources, and it's also the fastest to deploy. We are investing in it now because the fundamentals are strong. There's benefits in the tax code for installing solar that was made in America and creating a market demand pull for us. But more than anything else, customers of electricity need clean, reliable power. And with solar being the fastest to deploy while electricity demand is increasing for the first time in decades, it's an exciting opportunity for solar. At Hemlock and throughout just to maybe give you a little bit of, maybe I'll stop there for a second and make sure that there's not any questions. Otherwise, I'll talk about some of our further plans.
Go ahead, Dave.
Yeah, my question is, how long does it take to go from, uh, from an ingot to a solar panel as per se? I mean, how long does it take to make the finished product?
Um, it's probably 3 to 6 months, but that's a lot of that is just time with logistics. If everything was co-located, it'd be, a week. But because
Sure.
everything's not co-located, there's just a lot of transit time in the supply chain.
Gotcha. Thank you.
Yeah, go ahead, Phil.
Yeah, on your chart of demand curve, it showed in the out years, like up to 2029, demand peaking and decreasing. And I was wondering if that chart was developed before the oil energy crisis in the Strait of Hormuz, and if that might uh, change your prediction of demand for solar in the outer years.
Yeah, good question. It was developed before the current oil spike. The other, I've been in, like I said earlier, I've been in this industry for 18 years, and at various times I've seen market predictions predict like a downfall or like an abrupt end because of policy. Suffice it to say, I've never seen the industry actually decrease in production. So, I personally think it'll stay pretty strong in that 50 to 60 gigawatt a year range um, of deployments, if not higher.
Yeah, go ahead, Jay.
I did a little research earlier today and looked up your company. Also, realizing it takes a lot of energy to make silicon. Um, I come to find out from the Michigan Public Service Commission that your company is the largest electricity consumer within the state, and you actually schedule, from what I understand, you actually schedule when those ovens are running to never occur during like really hot summer days where the grid is already overloaded from air conditioners. So I kudos to your company for being conscious of that. But I was really surprised at the amount of energy that you do require, which kind of puts this worry about data centers to shame. But you guys are producing a great product that's necessary in order for us to get off of carbon based and fossil fuels. So I appreciate that. But did you have anything to say, perhaps, about how you are being conscious of grid load when you do run your ovens? Because being the largest consumer in the state, that kind of puts you up there where the eyeballs are watching.
Yeah, yeah, good question. So yes, we are currently the largest consumer of electricity in the state of Michigan. I think soon to be eclipsed by some data centers. But electricity consumption is a huge cost for us, so we're super conscious of the rate that we pay. And one of the things that we've done with consumers' energy is really encourage them to give us a look through to what is actually going on in the market and give us some of that pricing exposure to real-time electricity rates. So the discussion that you're referencing, there's actually a white paper out, if anybody cares to read it, that I wrote with a third party called Watt Time, WATTTIME, and we did a comprehensive study on using time of use rates as a marker for the carbon intensity of your electricity purchases. And what we did in the facility was utilize our capability to ramp up and ramp down on nights and weekends to get cost savings on our rate, essentially because we're using electricity when other people are not. And what we wanted to try and determine with watt time was what's the carbon intensity of the grid at those times when we ramped up and used more and then ramped down and used less. And it's in the white paper. It's not a real strong signal in Michigan yet, but it's there, and it's an opportunity for carbon reduction for us. And then, from a grid scarcity standpoint, we are what's called an interruptible resource for the grid. So MISO, who operates the Mid Intercontinental System, from Louisiana up to Manitoba can call on us to ramp down our facility within 30 minutes in the time of extreme emergency. So, we might get called every 2 to 3 years. We did get called in January during some extreme cold that we had. But yes, we are basically a virtual power plant on the demand side instead of the supply side.
Thank
Yeah,
you.
Phil.
That's very good. Thanks.
Yeah, Phil, am I right in assuming that because you're such a use so much electricity, you don't really have backup power per se, do you?
No,
No.
nope.
Yeah. Go ahead, David. Oh, you're muted.
There we go. All right, here, is that better?
Yep.
All right, good. All right, question to you. You had mentioned that you guys were looking at foreseeable investments in the near future based on what you guys are seeing. Now, when you mentioned that, were you talking more about what your company personally was going to start developing or getting involved in, or were you looking at market-wide as far as how the sectors are running and what you're possibly looking into investing as a company?
Yeah, I'll give you a little bit just about what we're doing as a company here. It's a good segue. So we've done a couple projects recently, and I'll just kind of walk through those. Over the last 18 months, we made a major investment. We call it Project Helios, in our capabilities and capacity to ramp additional polysilicon production for the solar industry as we saw the effects of the capital investments made because of the Inflation Reduction Act. We saw an increased demand for US-based polysilicon. So we've recently made approximately a $300 million investment to further expand our solar polysilicon production. Additionally, we've continued to invest in our semiconductor facility. A lot of what you read about today is the next generation of chips, right? The new TSMC facility in Arizona, additional Intel fabs in Ohio, and AI is all the rage. Those chips require more and more advanced semiconductor grade polysilicon. So we have recently invested in the building, the bottom of the picture here, to do increased cleaning and production of polysilicon for the most advanced semiconductor chips. I'll show you a quick video on that as well. So that building I just showed you is now quite proprietary what's inside of it. Trust me that there's a ton of equipment that I don't have pictures of, but it is actually up and running now and starting to supply material for those most advanced chips. And then more recently, what we've also been able to complete is our solar wafer facility. This is directly across the street to the west of Hemlock Semiconductor. So polysilicon makes the long and arduous journey of about 2,000 feet across the street and is produced into those wafers for the U.S. solar industry. The investment is actually, so if you don't know who Corning is, Corning Incorporated, like I said earlier, is based in Corning, New York. Its first product was to make the glass bulb for the Edison light bulb 175 years ago. And it's continued to do a lot of materials innovation. It makes the diesel particulate filters for semi trucks, tons of ceramic technology. It does a lot of material conversion, making the display on your TV, the Gorilla Glass on your iPhone, the fiber optic cable powering the AI revolution. And what it's also now invested in with its investments in Hemlock is further investment in the solar industry. The facility in Saginaw County is Corning's largest ever single site expansion. And that's saying something for a 175-year-old company. There's approximately 1,500 people at the facility working every day. And between the two facilities, there's about 3,200 people on its single campus. So looking ahead, what we're looking at is, continuing to get into the solar market. It is a highly competitive global market, but Corning and Hemlock have the right people, discipline, quality, and technology to scale to success. And we're here for the long term. And when we look at 2026 and beyond, we do see a continued growth in solar. We have to get these assets fully up and running and utilized. And we'll have a continued focus on operational excellence to build over the future, over the long haul. So that was everything I had. More than happy to answer more questions that people may have as well.
Yeah, go ahead, John.
Well, thank you very much, Phil. This is a fascinating presentation, and I'm a proud Michigander to have such a great company located within the state. There have been a lot of attacks on solar, both at the federal and state level. And you pointed out that, in fact, solar is the cheapest way of generating electricity. And yet, a number of entities and some parts of various political parties are making solar out to be the actual problem on why energy rates are going up. So I'm just wondering whether your company actually gets involved in politics at the state and federal level, because there almost seems to be a struggle between the older legacy fossil fuel companies and the new companies like you. And the irony is that you're not new, but the solar industry. And so I'm wondering whether, in fact, your company gets involved in political matters in one way or another. And if I'm asking a sensitive question, that's fine. You don't need to respond. I'm just curious.
Yeah, I mean, obviously, policy is important. We do try to keep a pretty low profile. When we say we're going to do things, we do them, and we deliver on the capital investments. We really try to show, not tell, and don't get too involved in the kind of the politics side of solar. And the U.S. solar industry has been successful, as you saw in that bar graph. in growing consistently year over year despite the challenges. And I think at this point we're kind of letting the economics speak for themselves.
Sounds good. Thank you.
Go ahead, Abraham.
I'm curious if you export any of your products outside the United States, and which products and where? To where in the globe do you export?
Yeah, we do export. The semiconductor industry is mostly based in the United States and East Asia. The solar industry is mainly based in the United States and Southeast Asia. So yes, we do export.
Well, Phil, as we all know, there's been a lot of talk about China's supremacy in kind of this sort of area and other areas too. And I know there's been initiatives to try to bring manufacturing back to the United States. It's like John mentioned. It's great to hear that you've been here for a long time and are an important part of the solar supply chain. But I'm guessing that from your perspective, kind of those policies to kind of bring the solar supply chain back to the United States is a real positive move. Is something that should be promoted. I would assume that makes sense to you folks, even though you're an international company. Uh,
Yeah, I think you're, just more broadly than solar, I think you're seeing in many industries throughout the world right now that there's kind of a push towards regionalization of supply chains, because we all realize that, through COVID, through various conflicts throughout the world, that supply chains that are reliant on one geography are not very resilient, right? So, yeah, we're continuing to encourage more investment in the United States, and excited to see more and more.
I'm kind of assuming too that one reason you're here in Michigan is, of course, electricity is very important as a cost, but you have you probably need skilled, talented workers, and at least we kind of have thought that that's one of our strengths in Michigan, right? Is engineering and technical skills, and it seems like your company's a good example, right? Of you don't need low wages to compete. What you need is kind of quality staff and good technology.
Yeah, well said.
Yeah, yeah. Go ahead, Marcia.
I just have a simple question. I was wondering while I was listening to this, it's a wonderful story, if silicon will continue to be such a vital element of all of these tech products and solar and so on. Is there any competition coming from some other place for a different kind of element for the solar panels, for instance, or the other items?
Great. Yeah, great question. Really, really good question. So, you've probably heard of this, like things like tandem modules or perovskites and um, other technologies. And even when I started my career in 2008, there was a lot of discussion around other thin film technologies, whether it was SIGs or some of these other technologies. Silicon has continued to be the best available technology, and the learning curve has not slowed down yet. There are theoretical maximums to the efficiency of a solar cell in the traditional crystalline silicon design. As you look forward, 10, 20, 30 years down the technology roadmap, a lot of people are starting to look at perovskites, um, which is another semiconductive uh, device that's made from fairly readily available elements. There are various chemistries that you can use to formulate a perovskite, and they all behave a little bit differently. To make a long story short, I've been hearing about perovskites my entire career, and they're always 3 years around the corner. However, the technology is starting to get better, but all of those technologies still use a silicon solar cell as the bottom cell, and then they layer the perovskite on top to get an efficiency boost. So I don't think silicon is going anywhere soon. It continues to get cheaper. It continues to get more efficient every day. And then some of these next gen technologies are just built on top of the silicon as it is.
Thank you.
Hey, Phil, with the growth in both solar and electronics, computer chips, and is there any major barrier to kind of a rapid expansion of kind of capacity that, or is there enough, I guess people, expertise to kind of ramp up, or are we going to have in some ways, maybe a hard time meeting the demand for the like the products that you're producing?
Um, I think it's a hard question to answer. As you go further up the value chain from module backwards to the solar cell and wafer and polysilicon, the biggest barrier is it's just super expensive capex to build. So you have to have some long-term certainty to make those capital investments, but I don't foresee any short-term or medium-term constraints in the market.
That's good to hear. Yeah. Hey, Clyde, go ahead.
Phil, is there any work going on in generating thin film? Uh, like the amorphous silica used to be.
Um, there's a little bit of work there. I mean, obviously, like the perovskite stuff that I talked about earlier, and then there's some cadmium tellurium thin films made by First Solar, but predominantly, especially outside the United States, silicon is still the dominant source for solar cells and modules.
Go ahead, Paul. I can't hear you. Maybe you're on mute. Oh, you are on mute. Yeah. Let's see if I can. There you go.
Cannot
Oh,
hear him.
still can't hear you. Yeah. It doesn't show that you're muted, but Lexi says, is your microphone connected?
Well, why doesn't Paul just post his question on the chat
Yeah.
and John
Yeah.
can
Go ahead.
read it
Yep.
out loud?
Yep. Go ahead, Dennis.
Thank you, Phil, for sharing this information with us. It seems like the solar panels are given like 25, 30 years or more. They're still producing once that time comes, but they figured that is their typical lifespan, I believe, or something like that I've been told. What wears out on them? Is the silicon becoming deteriorated after time, or is it something else uh, in the solar panel?
Yeah, I mean, this would be a better question for some of my R&D colleagues, but typically what you see today is that the warranty that the company provides is 80 at year 30, they're still guaranteed to produce 80% of the nameplate output. So there's a couple options that you have at end of life. You can use them for something else. You can leave them installed. There's really not anything that just goes wrong. But when we see failures in the field, a lot of times it has to do with like the sandwich. And what I mean by that is glass, the solar cell, and then the glass and the frame has somehow failed mechanically. And there are some physics issues when the p-n junction is created at the solar cell that it's called LID in the industry, or light induced degradation over time, where you'll see this deterioration in performance. But no, the silicon, it's 100% inert material. It doesn't go bad over time. But the solar cell itself will start to see a deterioration in performance, whether the bus bar wears out or the connection's bad or something happened to the glass sandwich. But when you think about stuff that you buy in general, like I don't think you buy a car today expecting that it'll still be 80% as good as the day you buy it 30 years from now. So it's actually pretty impressive.
Hey, Phil, one of the questions in the chat was there's no relationship between Corning and Dow Corning, is there?
Yeah, it's a good question. So Hemlock Semiconductor was kind of born out of Dow Corning. Dow Corning does not exist anymore, and it was fully purchased by Dow Chemical in 2016. So there was a historic relation between Dow and Corning and Dow Corning, but no, that there's no ownership relationship between Dow and Corning at all anymore.
Yeah, that's kind of history. Go ahead, Abraham.
Can you tell us something about the recycling industry and possibilities of the current product?
Yeah, there's probably more recycling in the EU at the moment because of just regulations and laws and end of life management. There is some solar recycling in the United States. It's rather infant at the moment because if you think about just the volumes installed, the vast majority of the volumes of solar panels have been installed just in the last 5 to 10 years. But there are facilities like Solar Cycle in Arizona and others trying to start up. When you think about the mass of a solar panel, the vast majority is either the glass or the aluminum frame. Silicon itself is a very minimal amount of the percentage of the mass. So most people have focused on just recycling the glass and the frame at this point. But if solar panels are recycled, we're more than interested in trying to harvest the silicon out of them and process it.
Am I right in thinking that you don't do any of that now, or is it done on a minor scale?
We don't do any of it. We're
Yeah.
kind of trying to pay attention to others in the industry that are working on it, though.
Okay. Yeah. Other questions or comments?
Thanks.
I think Abraham's got a question, John.
Go ahead, Abraham.
Maybe not. I may be wrong.
No, I was just slow in removing my hand there.
Well, I have a
Okay.
question. I have a real basic question. Where do you actually get the raw material of silicon from? Where is it mined? Or
Yeah, so a material called quartz is mined. All of our sources are in North and South America. Quartz is silicon dioxide. Chemically, it's the exact same stuff as beach sand. At typically pretty close to the mine itself will be a silicon smelter. So the silicon smelter takes the quartz, which is SiO2, and strips the oxygen off of it through a reduction process in a facility that kind of looks like a giant blast furnace. And then that metallurgical grade silicon is about 98% pure silicon and then 2% impurities. Whether it's like iron or magnesium or carbon, and our job is to remove that last 2% of the impurities.
And you're using most of your electricity to do the melting, right? And is there any potential to change that process to make it more efficient, or is it just the way it is?
Yeah, good question. Most of the electricity consumption is in the deposition process. After you refine the silicon in a chemical process, you have to turn it back into a solid. So think of like a giant Edison light bulb. Look on Google, it's called the Siemens process. That's where most of the electricity consumption is. It's, when you think about industry and where industry is going, so many people are focused on electrically driving their processes and not as much thermally. We have a very electrically driven process. And, it's really not, I don't know how else we would change it at the moment.
Well, we got a few minutes left if somebody has some additional questions or comments. Go ahead, Tom. You're muted.
Paul, you mentioned earlier the white paper, and I was curious if that's available or where it's available in terms of having us.
Searching for it right now. It is publicly available. Let me find it.
Phil, are your employees represented by a union?
No.
Okay, go ahead, Marcia. Ask your question while Phil
I
kind of
have another
searches.
Okay. Does the company install solar panels to create any of your own electricity that you use in the process of doing all this work?
No, we work on that with Consumers Energy. Right? We don't have any like direct installation of. We don't install the solar panels ourselves.
Okay, I think we have time for maybe one more question, and as Phil kind of looks for the source of the article.
I'll throw it in the chat here.
Oh, good. Oh, wow. Okay. Did you see that, Tom? Can't hear you.
I said I'll get it. Thank you.
Okay, super. Okay. Well, Phil, thank you very much. This has been very interesting, and I've heard of Hemlock Semiconductor a long time ago, but I've always been aware that it's kind of you're a hidden treasure that a lot of people aren't aware of how big you are.
Yeah.
And your important role in the solar supply chain. So thanks. I'm glad you had an opportunity to kind of talk to us and kind of explain what you do, but also where you're going, because that's of great interest to all of us. And yeah, thanks again. And hope to see everybody next Thursday. We're going to have a member meeting next Thursday. And so we'll be sending out a notice. Take care, everybody. Have a good weekend.
Right.
You too. Thanks, John.